Hello, Maritz here. In this video we should look at polynomial division, and to start with we just look at an ordinary long division. Let's say we want to calculate 678 divided by 5. Of course, for this we don't need to do long division, but we'll take it as an example. I mean, I would in practice do like this, that I would take 678 times 2 divided by 10 instead. 8 times 2, that would be 16. 7 times 2, 14, that would be 5 here. And 6 times 2, that's 12, plus the 1, that is 13, and divided by 10, that will be 135.6. But let's do this with long division. So, in other words, say we should split 678 of some currency, say 678 crowns, among 5 people. So we start with the hundreds. We can give everyone 100s, right? 6 divided by 5 is 1. We have handed out 1 times 5 is 500. We subtract that away. That will give us 100 left. We move down the 7. We can pretend now we change everything to tens. We split these 17 tens among the 5 people. They will get 3 each. 3 times 5 is 15. Subtract that away. That will give us 2. Switch that to single coins, so crowns. Still have the 8. That will be 28. 5 goes into 28 5 times. 5 times 5 is 25. And we have a rest of 3. So now we know that 678 divided by 5 equals to 135 plus 3/5. We could continue this by putting a decimal point here and think about we change the crowns to hundreds, or tens I mean. So 30 tenths of a crown. 5 goes into that 6 times. 6 times 5 is 30, and we have nothing left. So this could also be written as 135.6. So that is long division. There's several ways to write this, but this is the way I will use here. So now let's try the same thing, but on a polynomial. Let's say we take x squared minus x minus 6 divided by x minus 2. Okay. We write this with long division. X minus 2, x squared minus x minus 6. And we just look at the x here. How many times does x go into x squared? In other words, x squared divided by x. That will be x times. We have now handed out x minus 2's, so we multiply these together. X times x minus 2 is x squared minus 2x. Subtract away what we have handed away. So minus x minus 2x. Oh, that will be x plus 2x. That will be x minus 6. Many times x goes into x. That's 1 time. That is plus 1. We now handed out 1 x minus 2. So we write x minus 2 here. Subtract that away. Minus 6 minus 2. That will give us minus 4. And we stop there. That will be our reminder. So we can say now that x squared minus x minus 6 divided by x minus 2 equals x plus 1 minus 4 divided by x minus 2. So we can use this to be able to graph the function. So to start with, we know that from here, we know that we have a vertical asymptote at x is 2, right? Since 2 minus 2 is 0, and we can't divide by 0. So this value here, 1, 2, is not allowed. the graph will sweep away towards infinity at x is 2. We can also see that if x is fairly large, then this part here, we can say that if x goes towards infinity, then this part here will go towards 0. So in other words, we don't really need this when x is very large. So that means that this part we had over here will be a kind of asymptote too, and it's called an oblique asymptote. We can write this in here too. So 1 and a slope of 1, so this is the line x plus 1. So in some way these two lines should be asymptotes. So we have one asymptote at x is 2 and one asymptote is y equals to x plus 1. To figure out where the rest of the graph is, we can look at the y-intercept, for example. That will be at f is 0. And if we plug 0 into our original equation, we will get minus 6 divided by minus 2, or 3. So then we know the graph will pass through point 0, 1, 2, 3, so somewhere over here. Next we can look for any possible zeros, and to find zeros we only need to look at the numerator. So in other words, we check when x squared minus x minus 6 equals to 0. This we can solve by factorization. We can, for example, try to split the minus x in two factors that add up to the minus 1 we multiply x by. And that will give us 2 and minus 3. So in other words, we know that this can be written as x plus 2, x minus 3. So we now know that we have, by the null factor law, we know that we have x is minus 2 and x is 3 as our zeros. So we go back to our graph, and we know now that at minus 1, minus 2, and at 3 must be points where the graph passed through. And that allows us to basically draw the graph. It will have x equals to 2 as an asymptote. It will reach this point and then have the x plus 1 as an asymptote. On the other side, it will come from here, go through that point, and up, sweeping towards the asymptote from that direction. So that will basically be the graph. And we have this oblique asymptote, and we also have a vertical asymptote. We can actually check this on a calculator. We go into the menu, graph, enter the graph. So we have bracket x squared minus x minus 6 divided by x minus 2. We draw this and we basically get this. I will zoom out a bit here by going to the standard setting, so we see a little bit more of it. Yay. And we can actually add the graph of the oblique asymptote. So I will add x plus 1 here, x plus 1, and draw this, and we can see this asymptote here, right? And then we have also asymptote through x is 2 over here. So this is how we could use, first of all, use polynomial division and how that is working, and also how we can use that to enable us to draw graphs. Thank you.